Okay, so let's go ahead and get started. Welcome in everybody. This is the computer science principles review for units 4 and 5. Um, and before we get started, all the disclaimers and stuff. This is 5 Hive. We're not AP. We're not College Board, so you shouldn't take any of this as things that will definitely appear in your test or anything. And yeah, we don't represent any of those people. Um, Great. So, introduction. We're gonna kind of maybe go over the agenda of today. We're gonna go over, let's see, 9 different topics here. So we have all 3 things in Unit 4 and all 6 things in Unit 5. And the idea is just like the previous 2 reviews, we'll have some questions, and then we'll have some advice, and then we'll have a practice question or two for each little topic here. So yeah, the idea is I think this is going to be worth around a third of your exam total, right? So 11 to 15% for Unit 4 and 21 to 26% for Unit 5. So let's go ahead and get to work. Any questions before we get started here? It'll be pretty, if you've not been to one of these lectures before, it's pretty participatory. So I'll be asking a lot of questions to you guys. You guys can answer them in the chat. We'll do some polls for like the multiple choice questions and all that stuff. So it should be a good time, hopefully. How long do these last? Usually they're going to last around 2 hours. Um, Although this one may last a little bit shorter or longer. I'm not sure yet. I've never done these specific lectures before, so uh, we'll see how long. But yes, all the previous ones are on YouTube. Here's the playlist. There you go. And yeah, so I'll leave a couple links as well here. So this is this lecture schedule, and this is again the lecture feedback form. So if you guys want to leave any positive or negative feedback, you guys are welcome to. Always checking those to make sure I'm kind of updating lectures as needed and kind of adjusting my strategy as we go. All right, so let's go ahead and get started for 4.1. Yeah, no worries, no worries. So 4.1 is called the internet, and the very first thing is a computing device. And there's a lot of, as you can see, a lot of vocab that you have to know here. So just kind of getting through some of this vocabulary kind of stuff is going to be good before we can go on to some questions. So a computing device. What do you guys think a computing device is in general? Any ideas? Yeah. Yes, I love that answer. It's a device that can compute, right? Or can run programs. Yeah, absolutely, right? So it's a physical kind of device that we can actually hold in our hand sometimes, or at least touch, right? That can run a program or a computer that is a device and can compute. Yeah, exactly, right? So some examples that we can kind of think of are computers, right? Tablets, servers, routers, smart sensors, smartphones, metal detectors, right? All these kind of things can become computing devices, right? So now the question is, what is a computing system or a system? I guess it's kind of in the name, right? It's a system of devices, right? So you can kind of think of them as a group of computing devices that programs and works together, right? As a system. Yeah, a system that lets you run things on a computer, kind of, right? So a system that's specifically on a computer, you can think of as having multiple programs within it, right? But a computing system that they want you to kind of know is going to be a group of physical computing devices, right? So it can maybe like a network of computers, right? Oh, and actually, there's the next one, right? It's going to be a computer network. It's just a type or an example of a computing system where it's just a group of computers that work together that are interconnected and they're all capable of sending or receiving data between them, right? So it's a network of computers. So we'll see that is this the one? Yeah, so we'll see that these can be represented with graphs, right? And we have these different computers that are all interconnected. And we'll get to that when we get there, but that's kind of what a computing network is. So a path then is just a it's just between two kind of computing devices, just a sequence of directly connected computing devices that can begin at one specific device and end at another one that we call the receiver, right? So a path between two different computing devices just lets you uh, send data between them. right? Pretty straightforward, pretty like intuitive, I think, right? What about routing? Does anybody kind of remember the definition of routing? I'll give you a hint. It uses the idea of a path. Yeah, it's just creating a path to a specific destination. How info is transmitted from one place to another place in the sense of a path. How data is transferred, direct paths. Yes, all these are great answers, right? So routing we can kind of think of as the process of finding a path between a sender and receiver, right? So you can kind of connect different computers together so that you can find a direct, so you can find, it may not be a direct path, maybe an indirect path that goes between multiple different computers, but as long as you can connect, right, a sender and a receiver, then there you go. You've successfully routed a path, right? Okay, now we kind of switch gears a little bit. Bandwidth, we can kind of think of as just the amount of data that we can send between two devices, right? So, in particular, we can kind of think of it as the maximum amount of data that can be sent between two devices in a fixed amount of time. And does anyone remember how it's measured? What the unit is? Millibytes or megabytes? Yeah, it's bytes, something bytes per minute, right? Or so okay, we yes, bytes per second. Thanks for editing. Megabytes, there you go. Yeah, so megabytes per second, right? Or you can kind of think of it as going even smaller, kind of zooming in even more and just going straight to the actual bits per second, right? So megabytes are going to be if you're doing a lot, if that number is really high, then you can kind of shrink it down using the megabytes as your first kind of measure. But it's it it default will be bits per second. Absolutely. Yep. All right. So a communication protocol. So what's kind of unique about the internet is that they have open protocols, right? But what is a protocol in the first place? Anybody remember? Yeah, exactly. It's a set of rules, right? It's a method for transferring info that's standardized, so devices of any manufacturer can use them. Yeah, exactly, right? So it's kind of a method or a set of rules that we can use uh, that can kind of specify the behavior of a certain system, right? And so when we say kind of sending info between systems, that's kind of that is a type of protocol, right? Make sure devices work by following a set of rules. Yeah, exactly right. It really, as long as we remember that a protocol is a set of rules, then we'll be good. Now, how does the internet use it? Well, we can say it's the internet is kind of a computer network, right? That consists of interconnected networks with like kind of zooming in, right? So if we zoom out all the way, we have the internet. And as we zoom in, we have a series of different interconnected networks that each use kind of standardized non-proprietary, right? So we call that open protocols. And so those kind of open sets of rules are what allow like oh boy, 4RM44N. I'm sure there's a way to actually say that name, right? Probably Arman. Um, to what they said was you can standardize the communication between all networks or manufacturers, right? So everybody can use it. Absolutely. Yes, I got it right. Let's go. First person to get it right. No worries, I got you. Um, the four kind of looks like an A, so I figured that's probably what it was. All right. So access to the internet then depends on um, being able to kind of access these protocols, right? And so we need a computing device that can actually be internet connected, right? And so if we have that, then we can go ahead and connect to the internet, and then of course interact with all these different computers and computing networks. All right, so routing on the internet is dynamic. What does that mean? So what is dynamism in the sense of routing? What do you guys think? Adaptable to scale, right? Yeah, it can change. It's not set at a specific time, or it's not set before you actually use it, right? If it was set before it would be used, we call that static, right? But it's in this case, it's not. It's dynamic, which means as we use it, the protocols and the routing actually can change, right? So the different paths that we determine we need to go on can change depending on, say, if one path is down, right? Or if there's an internet outage, right? A service outage, then we'd have to shut down all of the paths that go through that particular network. Then what we can do is say, okay, well, let's just go ahead and change that route that we take. And that's why it's called dynamic, right? Because we can change it depending on the different conditions that we're at. So, yeah. Any questions so far, by the way? I know we've covered a lot of vocab. So we've all the way through dynamic. Okay, cool. So let's keep going then. Of course, if you guys have any questions at any point, you can just put them in the chat and I'll read it. Scalability, uh, what Armand kind of said was the internet is adaptable to scale, right? So what that means is as it grows larger, we can, as the system, the capacity of the system can change to accommodate that change in size, right? And that's pretty much all that means, right? If there's more people and then there's going to be more demand, right? And so there's going to be more stress put on the system. But if that system is scalable, then it'll be able to handle that stress. So data streams pass information throughout the internet by breaking down data into smaller bits called what? This is pretty something we should, just have right off the top of our mind, right? Memorize packets, right? Absolutely, right? So if we have a large piece of data and we need to transfer it, right? For example, in a text message, then what'll happen is that large piece of data will get broken down and then sent in bits, and then at that destination, it'll get reassembled, right? And so what we say then is that these bits that it breaks down into are called packets. So, okay, what happens when it reaches the destination? We just kind of went over that, right? It gets reassembled. Now, let me ask you a question. Do you guys think that packets get transferred kind of sequentially, or it gets just kind of shoved into the data stream, right? And just kind of random order? Like, how do you guys think it works? Depends on which method of transportation. Okay. So, what do you mean by that? That's okay. Yeah. So it just depends on what kind of protocols and kind of routing we use, right? But one thing that's kind of common between all of them is that there's uh, kind of chunks of data and metadata, right? So metadata, which is used for kind of routing the packets between the origin and destination. So for example, it'll have kind of the correct order that it's going to be needing to be kind of reconstructed with as metadata, right? And so, attached to that piece of data is actually another piece of data that tells it how it can be reconstructed, right? So it'll always be like that, no matter what the transportation system is. But as you guys were saying, different transportation systems have different kind of ways to break it down. Do you have to know about UDP and TCP for the exam? I'll read for you the exact wording in the CED, and you can choose how much you want to know about it, right? It says, quote, IP, TCP, and UDP are common protocols used on the internet. And that's all it says. So if you want to just know that it exists, then you probably are good. But if you wanted to make sure you're really good, then you can go ahead and know everything that compare them, right? Must not have paid attention. That's okay. That's okay. Um, multiple choice questions be like, what is metadata? A backup of copy of data, data about data, how many necklaces the file creator was wearing, or the AP exam answered. Yeah. Yeah. So it's pretty straightforward, I think, most of the time, but there are going to be some tricks, so it's good to know. Um, I think it might ask a question asking if UDP or TCP is better. It could, you know, in a specific case, I'll say I've never seen that be the case, but I wouldn't say it would hurt to know which is better in what case, right? All right, so some common methods, some common protocols used on the internet. We just kind of went over them, right? IP, TCP, and UDP. Oop. So what year did I take APCSP? I took it in 2022. So like 3 years ago now. Boy, it's been a long time. All right, what is the World Wide Web? So, what can we say 3 years ago? Yeah. So what protocol does the World Wide Web use? And actually, what is the World Wide Web in general, guys? What do you guys think? System of linked websites and pages and files that operates using the internet. That's a perfect definition. So it's uh, I'll read you the one in the CED and you can see how good it was. The CED says it's a system of linked pages, programs, and files, and that's it, right? So yeah, it's a part of the internet. And the protocol it uses is called HTTP, right? So if we go to google.com, right? Google.com. What is it? There it is. HTTPS, right? The S just stands for secure, which means it's a more secure version of HTTP, but we see that all web pages are going to be using that HTTP. All right. Yeah, so the protocol is HTTPS or HTTP, right? S is just standing for it's a more secure version of it. Okay, the World Wide Web then uses the internet, as we said. So as far as on the test, we need to be able to explain how computing devices work together in a network, explain how the internet explain how the internet works, and explain how data is sent through the internet via packets, and of course, describe the differences between the internet and the World Wide Web. I do think the S is just standing for secure. It may also stand for some other thing, but I could be wrong. All right, so let's do this practice example. Create poll question. So this is coming straight from the APCSB CED. So this is an official question, not one that I made up. All right. So which of the following best explains how data is typically assembled in packets for transmission over the internet? Go ahead and read each choice. Give me your answer in the poll. See what you guys think. Okay, so it looks like A is our top choice with B also getting some votes. So let's read them. A says each packet contains data to be transmitted along with the metadata containing information used for routing the data. B says each packet contains an encrypted version of the data to be transmitted along with the data along with the metadata containing the key needed to decrypt the data. C says each packet contains only the metadata. Well, that we know that's wrong because it has to include the data itself, right? And each packet contains multiple data files bundled together. We said that's also wrong because packets are themselves the smallest bit that you can have, right, of data. Um, Star Revamp says, I think B is a trick because packets aren't encrypted on their own, but are encrypted by other things. Yeah, so that's exactly right. So um, as far as kind of transmitting information over the internet, the packets are literally the data. And so then that data kind of when it's reassembled can be encrypted, but as far as when it's being sent, it's being sent kind of as just the packets, right? So we notice we didn't talk about encryption yet, and so that's kind of there as a trick for you guys. So yes, A is going to be our right answer. So any questions with this question here? Bit of a tricky one, right? All right, let's go ahead and move on. Here's another question here. I feel like every time the word only is in an answer, it's probably a trap. That's a really good kind of test taking tip, right? It's like anytime you hear something like with always or only this or something like that, it's a lot of times a trick. All right, let's try this one here. Question A, B, C, and D. Allow multiple answers. Let's give it a shot. So, a cloud-based music streaming service sends a personalized playlist recommendations to users based on their listening habits. Which of the following are true statements regarding the potential impact of network connectivity and service disruption on recommendation delivery. So we have A, which is recommendation delivery might be delayed if the user's device experiences temporary loss of internet connectivity. B, if the data center serving one region goes down, users in that region might temporarily stop receiving upload recommendations. C, playlist recommendations are preloaded onto devices and unaffected by network connectivity. D, all users worldwide will stop receiving recommendations if any single data center goes offline. Give it a shot, see what we think, and go from there. All right. It looks like we're all getting A and B, and I would agree. I think A and B are our strongest choices here. We have one vote for C, so we'll go over why that is not the case, and also D as well. But let's take a look. So, recommendation delivery may be delayed if the user's devices experiences temporary loss of internet connectivity. Well, of course that's the case, right? Because if you lose your connection to the internet, then your device is no longer able to become a receiver, right? So remember, we have a sender and receiver in all uh, kind of transfer of data. And so that receiver needs to be connected to the internet to receive the data, right? Just like the sender needs to be connected to the internet to send the data, right? So this has to be true because if you're not connected to the internet, then you can't receive data, right? Okay, let's go to B. If the data center serving one region goes down, users in that region might temporarily stop receiving updated recommendations. Again, kind of same idea, right? If your region is out of internet, you're not going to be able to receive information, right? Let's go to C. Playlist recommendations are preloaded onto devices. Well, we know this is not true because we're streaming, right? So streaming implies kind of getting information, getting data from the internet. And then D, and it's also cloud-based, right? So cloud-based means we're using the internet. And then D says all users worldwide will stop receiving recommendations if a single data center goes offline. We know that can't be true because the internet is dynamic, right? So if it's dynamic, then we know that we are going to be able to change our routing based off of and like the status of the data centers, right? So if a single data center goes offline, we're using dynamic routing to route the information through other paths. You might be a little less cooked. Good. Good. All right, so let's go on to 4.2. So, what is fault tolerance? Anybody have any ideas? Not related, but is there a reason why premium Spotify users are able to use the app without internet connection? Yeah, so the reason is because they while you have internet connection, they actually download the songs that you're listening to onto your device. So that way you don't even have to connect to the internet to listen to those downloaded songs. So the device has it, absolutely. Right, so fault tolerance is when the connections are redundant, so stuff can be routed differently if one connection or node in the network is not working. Yeah, exactly, right? So if we have multiple kind of uh, paths to one particular node or one particular computing device, then we can say that we're going to be able to route uh, kind of dynamically, right? That's why, for example, we were able to not kind of have one connection cause a whole uh, disruption, right? Because um, there's multiple redundant paths. And so then again, that is also what redundancy is. And so redundancy kind of builds what we call a fault tolerant design, right? So fault tolerance is an adjective that we can use to describe, or fault tolerant is an adjective that we can use to describe a particular network being full of redundant paths, right? So if one computing device fails, what happens to the packets that were originally routed there? Well, they just get routed elsewhere, right? Because it's dynamic. Again, here we go. The internet has many redundant paths, thereby increasing scalability. What do you guys think? True or false? Obviously true, right? Yeah, absolutely. Right. So for the test, we want to be able to describe the benefits of a fault tolerant system, explain how a given system is fault tolerant or is not fault tolerant, right? And identify vulnerabilities to failure. So kind of vulnerable or vulnerabilities are just the opposite of redundant paths, right? Which means it's just not redundant. So then it's vulnerable, right? Because if you happen to have one data center go down and it's a vulnerable system, that could impact many other data centers, right? Or um, computing devices. So let's do this practice question. These are the types of questions you'll see with this type of for fault tolerance is you'll be given a graph of computing devices with paths routed between them, and then you'll be asked questions about them, right? So what is the minimum number of connections that must be broken or removed in the network before computer B can no longer communicate with computer E? So let me create a poll here. Paths question, go A, B, C, and D. See what you guys think. All right, so it looks like C is our winner, but A and B also have some votes. So let's take a look at the question. We see that the question is asking about computer B and computer E, right? So that would be this computer and this computer here. So we can see that they do indeed have a path directly connecting them, right? So they are able to directly communicate. So if we kind of snip that line, then we can say, oh, there we go. B and E can't directly communicate, right? But we also need to consider implicit communication as well, which means that if we look, we can see B goes to A, which goes to C, which goes to D, which goes to F, which then goes to E, right? So if this line was snipped, then we can say that B can still communicate with E, albeit implicitly, and the reason why I can do that is because this line here was actually a redundant path, right? And so this is a really good example to illustrate that, right? Because we can see that it can still communicate with E if we were to kind of get rid of this line. So we would also then need to get rid of this line if we wanted to completely cut off B from E, which means the answer would be C2. So kind of one way of thinking about this as well is whenever we're kind of given this type of, well, what's the minimum number of connections that must be broken? Very common question type that you could very possibly see on your test. The way I approach it at least is just look at the two, B and E, and see which one has the minimum number or the lower number of connections, and then just cut all of them. Right? So if we cut all of the connections from B, then we isolate B from everybody, and then they can't communicate with E, right? So that would be the minimum number. And then of course you can double check, right? If we cut, for example, this one, C to D, well, that would get rid of this line, but with this could still like go there, so we'd have to get rid of that one. Again, that's two, right? So we can kind of double check our work by cutting off other lines as well. But that kind of cutting the lower of the two is always a good option. So any questions with this question? Also, welcome, Nate. Welcome in. Okay, if there's no questions with this one, then let's go on to this one. This is just the same picture, kind of told to us again, or given to us again, just kind of so I don't have to, scroll up and down for you guys. So, question, here we go. Which of the following statements about security in the network is true? Let you guys read the choices and answer. Okay, let's go ahead and take a look. You guys are again welcome to always, kind of continue answering as I kind of explain this, right? But it looks like C has one more vote than D, but they're both pretty high. So C and D will say are practically tied. And then we have a few votes for B as well. So um, let's take a look. So we're saying it's not A, right? So a lot of us are saying one is out. So let's take a look at what one is and see if that's true. If computer E goes offline, then all the other computers can still communicate with each other because the system is fault tolerant. Well, generally, I would say this is a pretty fault-tolerant system, although what I would say is that many of the devices inside of this system only have one route between them, right? So for example, F to D, D to C, C to A to B, right? G to E. You can see there's one kind of line between each of them. So actually, this isn't a super kind of fault-tolerant system, right? Um, but what we can say is that, for example, if we get rid of E here, we could say that F still communicates with D to C to A to B. Great, right? So all of these can still communicate, but we have to consider G here, right? So if we get rid of E, then you guys are absolutely right in saying that this not everybody would be able to still kind of communicate with each other because G would be isolated, right? So one we can say is false because no, not every computer can still communicate with each other, and the system is kind of fault tolerant, but not really, right? But either way, one part of it is false, so we'll say the whole thing is false. So yeah, great job. Okay, let's go to two now. The optimal path between computers B and F is shorter than the optimal path between computers C and E, right? So this is a little bit tricky because right off the bat, you might think, okay, well, B to A to C to D to F, that's kind of a good path, right? And C to E, C, there's only one way you can get from C to E, right? Which is C to D, D to F, F to E, right? And so from there, you think, well, that way is actually shorter than the other way, right? So that would make this one false. But we also have to consider all the possible ways to get from B to F, which means that we have to then consider B to E to F, right? So this is actually shorter than C to D to D to F and F to E, right? So that's three kind of links. This is two links, right? So it is the case actually that B to F is going to be shorter than C to E. Do we see how that works? Are there any questions there? Don't mind my like super loud chair. I don't know if you can hear that. Is there a recording of past CSP ones? Yes, absolutely. I'll send the link right now, actually. Let me see if I can share this. There you guys go. All right, so that case, then we can see, yeah, of course. So in that case, we'll say that two is true, which means then we need to, well, if we know one is false and two is true, then we know it has to be D, right? But just for kind of to go over it, let's go through three as well. A communication line A and F would be useless as they can already communicate with each other. Well, A to F would A to C to D to F. That's kind of one, two, three links, right? So if any one of those links fail, then A cannot communicate with F, right? But if we directly communicate, or if we directly add a line from A to F, what we would say then is we are building a redundant line, right? So that in the case that, A to C or C to D or D to F fail, we always have that redundant line between A and F that we can fall back on, right? So it would not be completely useless because it would still provide a redundant line and build the fault tolerance of the network as a whole. So we would say that this is false. So that's again why then D is the answer. Cool. Any questions with this question or these and either of these two questions? Okay. In that case, let's do 4.3. So parallel and distributed computing. So what is sequential computing? Anybody have any ideas? And particularly, what's sequential versus parallel? You hate this? Don't worry, we'll make it super easy right now. It's when computers do processes at one time. Yeah, so kind of if we do it kind of task by task, that's going to be sequential, right? So task one to two to three to four is going to be a sequential ordering, right? So it's quite literally a sequence, right? One, two, three, four. Parallel process, as Armand says, is multiple processors doing multiple processes at the same time. Yeah, exactly, right? So if we have multiple processors on one computer kind of splitting up the work, then we can say it's going to be running, those tasks are going to be running in parallel, right? So for example, so let's write this out. So we say that 1 to 2 to 3 to 4 is going to be sequential, right? Parallel, though, is if we say have a computer here. Let's see if I can insert a table. So within one computer, we know that there can be multiple processors, right? So say two processors here. And actually, I'm going to add one column left and say P1 and P2, right? So if we have multiple processors, then what we can say is we can split up the work to say have 1 to 2 on the first processor. See if that works. No, it's not gonna, huh? That's okay. And have 3 to 4 on another processor, so that really inside of this one computer, we'll be splitting up the work based on the processors, right? Even further then, we could do processor 1 has task 1, processor 2 has task 2, 3, and 4, right? So that we get super kind of spread out in terms of the number of processors that we're using, right? Can we please go over past free responses based on the College Board? I don't know what PPRS stands for, but yeah. So I don't currently have past papers. Gotcha. Yes, I don't have a or personal project references. Gotcha. Yes, yes, yes. Gotcha. So I don't currently have a schedule like specific for that, but I'd be happy to go over like them. I'm gonna do one the day before the exam, also the day before that. I'm gonna have two different review sessions. So if you guys want to bring those ideas to there, I'd be happy to do that. But you can find everything on the lecture schedule, calendar view. So that's gonna be the 14th and the 13th there. Yeah, I also will have a, let me see if I can pull it up for you guys. Sorry, it's kind of a brief intermission. One second. So last year, when they first introduced this, I went ahead and made up a bunch of possible kind of examples. Again, those are just examples of my own writing, so they're not nearly kind of, official or anything, but I did go ahead and create a bunch of them that you could use if you want to take a look at those. Okay, so back to this. Distributed then is, as you might expect, just pretty simply splitting up the tasks, but instead of on one computer in multiple processors, using just separate computers, right? So if we say kind of cloud-based distributed computing, what that means is over the internet, right, having multiple different computers or computing devices complete those tasks. So for example, 1 to 2 here and 3 to 4 on just different computers now, right? So send the 5 lecture schedules link. Sure, absolutely. There you go. All right. So comparing kind of the efficiency of computing solutions, then what we can say is we need to calculate the time it takes them to perform the same tasks, right? So we can, if for example, if this one takes kind of 50 seconds, maybe this one takes 20 seconds, then we can say that this one, obviously parallel, is going to be faster, right? And that's generally what you'll get because you're splitting up the work between processors, right? So how do we calculate the time of sequential and parallel solution? Well, if we, for example, are calculating the time for a sequential solution, and we know that, for example, tasks A, B, and C take 10, 20, and 5 seconds respectively, then all we need to do is just add them together, right? Because we know that, for example, in this example here, the complete time it's going to take in order to complete each one of these is going to be the time it takes to complete 1, then 2, then 3, then 4, right? So we just add those times together. Whereas if we're doing parallel, for example, what we do, so let's do the sample solution here for sequential. So that would be 10 plus 20 plus 5, right? Which is, let's see, 35 seconds. So now if we're doing parallel, what we can say is it is actually just going to be the longer of the two times that we have here, right? So for example, if the processor 1 gets these two tasks done in say 5 and then 10 seconds, and then processor 2 takes say 10 and 15 seconds, well, that's going to be 25 seconds here, right? Versus what was it, 15, right? So we can say that altogether then, this is going to take only 25 seconds, right? Because it's the longer of the two different processes. Sorry, two different processors, right? So, what we can say then is that if we know the two times on the two different processors, it's going to be the longer of the two. But no matter what, that's always going to be longer. Sorry, it's always going to be shorter amount of time than doing them sequentially, right? Because we're splitting up the work. So, as far as this example with two processors, we can say the shortest amount of time would be, however, we can get the shortest amount of time by splitting up the tasks as evenly as possible, right? So if we see that 20 is going to be the longest amount of time, then let's separate that one from then the other two, 10 plus 5. So we have 20 seconds on one processor, 15 seconds on the other one, and then what do we get? We say that the whole process takes 20 seconds. Does that make sense? Yes, absolutely. I can re-explain parallel processing. So all parallel processing is within one computer, we may have you guys probably are familiar with like like a 8 cores, right? Or 16 core CPU. I don't know. You may not be familiar with that. That's totally fine, right? But all that means is that we have 16, for example, 16 core CPU just means we have 16 different processors within our computer, right? And so if we have 16 different processors within this computer, or for example, in this example, we have two processors within this computer, then if we have a series of tasks to do, we can just split up those tasks between the two processors, right? So we have, for example, in this example, processor one is doing tasks one and then two, and processor two is doing tasks three and then four. And so you can see how with both of them happening at the same time, that this solution is going to take a lot faster, right? It's going to be a lot faster than doing all of them on one processor. Yeah? Does that make sense? That's all parallel processing is. So we're just splitting up the work on two different processors here, or however many processors they give you. So for example, in this case, sequentially, we would just add them up, right? Because just one processor is going to have to do the 10-second, then the 20-second, the 5-second tasks to get 35 seconds total. Whereas if we have two processors, we'll try and distribute them as evenly as we can. So we'll have one processor on 20 and the other processor doing 15. So now there's this thing called speed up, which is just basically telling us the the percentage, or it's not even the percentage, right? It's just this kind of metric that we can use to see how much faster the parallel solution is. And all that is the sequential solution, so 35 seconds, divided by the time it takes to complete the parallel solution. So whatever that's going to be, I don't even know. It's like 1.75 or something probably, right? But that's what we call the speed up of this solution. I've never seen that asked on a test, but that is in the CED, this kind of speed up metric. So we should know what that is. Real quick, what is this simplified? It's like 7/4, right? Okay. So as we said before, which one's going to scale more efficiently? Probably the parallel solution, right? Because um, they're going to be able to split up tasks more and then grow those amount of tasks more evenly, right? So the problem with this kind of this kind of parallel computing, and we'll get back to this one as well. But the problem here is that we see that we still have sequences here, right, in our parallel processing, right? So we still have some of the drawbacks of the sequential solutions because each process is going to have a sequence in each of their kind of processors, right? And so that's why the sequential computing can still kind of come back to haunt us. But if we use distributed computing, then we actually don't get this problem, right? Because while each computer may have separate tasks, we'll be able to distribute them onto each of their processors then, right? And get so um, just spread out that we're going to be able to kind of spread out most of the tasks as well. So that's going to be a lot less of a problem with distributed computing. Again, it won't completely go away, but it'll be a lot less of a problem. So for the test, we should be able to compare the problem solutions and determine the efficiency of solutions, all that kind of stuff, and then describe the benefits and challenges of using distributed computing as well. So any questions with what we kind of went over here before we do some practice? Okay, then let's do it. Nope, great. So here is The question, in a parallel computing system with two processors, each processor can execute one task at one time or at a time. One of the processors experiences a 10-second downtime during execution, so we can decide which processor that's going to be. The following table shows the execution times for each of the three tasks, 30, 20, and 10. So which is the best approximation of the minimum possible time required to complete all three tasks using the two processors? So what do you guys think? Don't forget about this 10-second run downtime as well. Great. So let's take a look at our answers. It looks like we're all in kind of agreement that it's going to be B. So that's great because it is B. So yeah, you guys are right. Let's take a look at how we would do that though. So if we have a 10-second downtime, we can kind of almost add another task here and just call it the downtime, right, as 10 seconds. Hey, Nandini, how's it going? Welcome in. Um, Not much. We're just finishing up Unit 4 right now, and then we're going to move on to Unit 5. But you can always rewatch the recording as well on YouTube. So all right, so for this one, what we say is then how do we distribute all of these tasks the most evenly, right, between two processors? So if we have, well, but we can kind of use that same approach that we did before, which is distributing 30 onto one processor and then the other two on the other one to get a more even distribution of 30 and 30, right? But one of them has to experience the 10-second downtime, which causes us to have an imbalance. So we have 40 and 30, and you guys remember that we always take the longer of the two, which is 40. So that's going to be how we did that problem. Any questions with this one before we move on to another one? This one's more straightforward. The next one's going to be a little bit tougher. Okay, let's take a look here. Parallel computing system with two processors. Oh, hey, Guac, what's up? Just came from World? Nice. How was that? Was that good? Question. Scary? Scary because of content or scary because of tests? Oh, lots of unit in one day. Gotcha. So, um, a parallel computing system with two processors has tasks with variable execution times based on the processor used, which means that it's not just going to be kind of the same time on either processor now. So we have to consider two different times for each task. So what's the best approximation of the minimum possible time to require to complete three tasks using the two processors? This one is a little bit tricky. So remember, to solve these types of questions, we need to find the best possible time distribution that we can get uh, by using parallel processing. So remember how we do that is to have the most even distribution as we can. So we want to have the closest time distribution between the two processors. Yeah, so these are pretty much kind of like a guess and check kind of vibe. So I'll give you guys a hint, and what but how we're going to do that is I'll just give you kind of an example run of what you might be able to do, right? So for example, if I do say 25 seconds on processor 2 and 35 and 40 seconds on processor 1, that's obviously going to be 75 and 25. But we see that that's not very even, right? Processor 1 is very much overloaded compared to processor 2. So we said that that's going to be kind of the worst possible runtime or the worst possible uh, kind of distribution. So we want to find the best possible or the most even, right? And by having the most even, we'll then have the least amount of time. So yes, you could just guess and check. So let's kind of go over it. It looks like most of us are saying A, with some of us saying D. So real quick, for those of us saying A, was that a guess or was that a you have a solution that works in 40 seconds? Actual answer. Okay, let me hear it. R on number one. Okay, so we have 40 here, and the other two on two. Great. That's a perfect answer. So what we do here is 40 on one and 25 plus 15, which is 40 on two, right? So now we have the most even possible distribution, right? Perfect. Great. So, how do we get that then is the question, right? So we could guess and check. That's great. What I tended to do, right, was how I mentioned that we could do it was to do kind of the minimum on either one, right? So for example, 20 here, then 15, then 30. But what do we see there, right? That becomes 45 here and 20. So we see that we could actually get it more optimized. So if it's the case that we have split kind of processing time, then we don't want to use that method because that's going to give us the wrong answer, right? Or it could give us the wrong answer. So what we need to do then is kind of compare the times between them, right? So this is only 5 seconds more than that one. So we may want to actually end up using this one, whereas this one is 10 seconds. So we may be able to switch over to here uh, and keep the other two like this. Does that kind of make sense? You didn't even remember learning this? That's okay. For some reason, I don't think I learned it in our class either. I think this is a relatively new addition, so your teacher may not be teaching this one. But you do need to know it, how to do this kind of stuff. So it's good to know. Yeah. So it's good to kind of review. You all collectively played Roblox. That's crazy. That's insane. I could not imagine that. I don't even know. How does your teacher get paid? I don't know. All right, so 5.1. Let's take a look at some beneficial and harmful effects of computing. All right, so real quick though, before we do that, any questions with our other kind of stuff here? Anything in Unit 4 that we need to go over one more time? Okay, then let's do Unit 5. So, and this, we're gonna have to kind of speed up a little bit here. No, Nandini, everything you missed was not just as hard. It's okay. Everything was, most of the other stuff was more intuitive. All right, so 5.1. True or false? People create computing innovations. What do you guys think? True, right? People can, yes, it's gonna be true. It's gonna be true because people are we were the ones that created computers, the internet, all that stuff, right? All right, true or false? The way people complete tasks often changes to incorporate new computing innovations. What do you guys think there? That true or false? What do you guys think? True. Yeah, absolutely, right? Because for example, if we take AI, right? ChatGPT, the lovely ChatGPT, lots of people were using ChatGPT to generate their code, right, for the create tasks. That's a great example of how people often change the way they do things to incorporate new computing innovations, right? I would say it may be good to create a rough draft or something, but you always want to double check ChatGPT's work and also understand what it's doing, right? So, true or false, effects of a computing innovation are anticipated in advance. I know, right? ChatGPT can never get a math problem, right? False. Yeah. So this one is going to be it's kind of a tricky one, right? Not all effects are going to be anticipated in advance, right? So there could be a new kind of unintended consequence of a computing innovation that we need to take into consideration, right? So that's something that we need to know. That's what you meant? Great, perfect. Yeah, some can, right? All right. An effect of computing innovation is either positive, negative, or neither. Is that true or false? It seems true, right? Now, let me ask you this question. Can an effect be both positive and negative? Yes, it could, right? Yes. So actually, this is going to be false, right? Because an effect can be positive and negative. So that's also what we need to do. Yeah, it's a little bit of a trick. I'm trying to make these more engaging a little bit, right? So instead of just kind of brainwashing, true, 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 true. So, I want to throw something in here a little bit. All right, true or false? Advances in computing have generated and increased creativity in other fields. I don't know why that happened, such as medicine, engineering, communications, and the arts. True. Yep, this is true. All right, so we also should be familiar with how computing innovations can be used beyond their initial purpose. So, for example, the World Wide Web is actually intended for rapid exchange of information within the scientific community, but obviously expanded, right? All of these things we should know about. So, targeted advertising is used to help business, but it can be misused at both individual and aggregate levels. Machine learning, this is all true, by the way. I'm telling you right now. Just these are things that we should be aware of, right? Machine learning and data mining have enabled innovation in medicine, business, and science, but information discovered in this way has also been used to discriminate against groups of individuals. So, can computing innovations ever be harmful? What do you guys think? Yes, right? They could have a harmful impact on society, right? The economy or culture. There's a lot of computing innovations that are harmful, right? Yeah, absolutely. Yeah, some of them are even making us dumber, right? Great. All right. Before releasing new computing innovations, what checks do responsible programmers do? This is more of a leading question because it's taken straight from the CED. But responsible programmers try to consider the unintended ways that their computing innovations can be used and the potential beneficial and harmful effects of these new uses, right? So we try as hard as we can to consider all of our effects, but we need to know that, there's some things that may not be able to be seen, right? Can computing innovations ever have unintended helpful effects? What do you guys think that is? Yes, right? There's just unintended effects on both sides, right? So, how so? Well, we can lead to advances in other fields, right? So, for example, you know, there could be kind of a computing innovation that it was intended to be used in, the science or say biology realm, right? That is actually can be transferred and used somehow in like the English realm, right? Or an arts way, right? So that's kind of an example, right? And then something else we need to know that is rapid sharing of a program or running a program with a large number of users can actually result in significant impacts beyond the intended purpose or control of the programmer. So that is something we should know as well. So for the test, we should be able to explain how an effective community innovation, sorry, can be both beneficial and harmful. And we also should be able to explain how computing innovation can have an impact beyond its intended purpose. So that's basically what we just went over here, right? So any questions with 5.1 here before I do a practice question or two here? Two practice questions. All right, so the way we're gonna do these are we'll go back to the spoilers because yeah, so if you go actually to the lecture schedule and go to the list view, go to CSP 4 and 5, it's this doc right here. All right, so to answer these questions, go ahead and put a double bar and then put your answers, right? So say A comma B or something, and then do a double bar at the end, and then you can send it. And we'll have both answers for both questions here. Yes, I will send this doc right now. So go ahead, take a look at these. Um, yeah, and you can also get the lecture feedback form as well. Sure. I appreciate the good reviews. But also, if you have anything constructive, I always appreciate that as well. But okay, so let's take a look at these questions as we're working and take a look, see if you can identify the answers and put them in the chat with the spoilers. Sure, you guys can use Armand's for question one, and I can create another one for question two, or you can or you can do the spoiler. I think the original kind of idea with the spoiler is if we have two questions, then you can put both of your answers in one message. Or we could do the poll thing. That's cool too. That's fine. Here's question two then. So you guys can use Armand's for question one and this one for question two. We will go over that. All right, so let's go ahead and take a look. A fitness app has launched a new feature that allows users to share workout achievements publicly on a community feed. The goal is to motivate users through social accountability and recognition. Which of the following is most likely an unintended negative effect of the addition of the feature? So most of us said A, which is users may feel pressured to meet unrealistic fitness goals. This is, of course, the right answer, right? Um, it's pretty much the only one that's a negative connotation, right? But some of us were wondering why D is not a right answer as well. And the answer is because let's take a look. Some users share more achievements than others to gain attention or status. Well, the whole goal of the feature was to allow users to share workout achievements publicly on a community feed, right? So this is literally the goal that we're trying to achieve, right? It doesn't matter kind of, what their intentions are per se to gain attention or status. But because the whole idea of the question was that we allow them to share achievements, right? So if they're actually sharing their achievements, that's the idea, right? That's the whole goal or the whole kind of that's the intended effect of the program, right? Or of this addition. So kind of being able to not only identify which are the negative versus positive effects, but also which ones are the intended versus unintended effects are key to these types of questions. But typically these are kind of straightforward questions, right? All right. So then looks like we all said C for this one. So a major city implements facial recognition technology in public areas to enhance safety by identifying suspects in real time. Which of the following groups is likely to experience both a positive and negative effect from this computing innovation? We have law enforcement officers, technology developers, citizens who live in historically overpoliced areas, or tourists visiting major landmarks in the city. Well, as we kind of all kind of guessed, it was indeed C. And the reason is because we have, uh, a positive effect that could be kind of, they are getting more effective policing, right? They're getting more kind of the correct kind of criminals, right? But a negative effect may be that if they're being historically overpoliced, this may actually intend or not intend. This may have the unintended effect of getting even more policing in that area, right? So there's both a positive and negative effect for that group. There's one more. Yes, so I'm gonna have one. Actually, I'm gonna have a couple. So, well, if we take a look at the calendar, I'm gonna have one here, which is just straight up gonna be giving you guys a practice test. You guys doing a full 3 hours of practice, and then that next day we'll go over that practice test, and the day before the test we'll have a last minute kind of Q&A. That's the plan. You will be there. Great, awesome. All right, so that's these ones. Any questions with these ones before we move on to the digital divide? Great. So. The internet access may vary by what conditions? That's the question. What do you guys think? Or in other words, what are some ways where internet access may vary? Like what statuses may you have that may allow you to have more or may make you more likely to have internet access? Yeah, absolutely. The geographic area that you're in, right? If, for example, you can kind of take it country by country, right? Obviously, there's some third world countries that don't have internet access, or even within the US, right? If you're in like a really remote area, you're not going to have internet access, that kind of thing. So geographic location is a big one. Anything else you guys can think of? Traffic, sure. The amount of people that are in your area that are trying to get on the internet, sure. Well, internet access, yep, poverty, great. So socioeconomic status is another big one, right? Financial state, yep, yep. Demographic characteristics, right? Those are another one, big one, right? And so these are kind of some conditions that we need to know that may prevent people from getting access to the internet. So where some people have access and the other ones don't, that is quite literally what the digital divide is, right? It's referring to kind of differing access to computing devices, so the actual devices themselves, and also the internet, based on, like we said, these types of factors here, right? So the digital divide can affect both groups of people and also individuals, right? So if, for example, if you live in an area that doesn't have internet access, then all of the people in that group can't access to it, right? But if, for example, you yourself are, say, um, part of a like if you're homeless, right, or something like that, where you don't actually have access to a physical computer, then that's something that you could have on like a burden on yourself, right? So you could, in fact, like I'm saying, then both groups and individuals. Does that make sense? All right. So true or false then? The digital divide raises issues of equity, access, and influence both globally and locally. What do you guys think? True, right? Yeah, absolutely. Great. So then how is the digital divide affected by actions of individuals, organizations, and governments? Well, it's pretty straightforward, right? If some individual prevents another individual, right, from having internet access, then that's part of the digital divide, right? Or for example, if you're in I'm trying to think of an example that's not on like an example question that I've done before. But if you say you are at a local fitness center, right? And I don't know, that wouldn't work. Okay, I'll just do an example that's like shows up in another like test or something. But if a country doesn't invest in internet, that could be, yep, a government one, if they don't invest in internet, that's great. Yep. If your job, for example, right, if you're not if your job's expecting you to have internet access, that is going to kind of contribute to this digital divide, that kind of thing as well. So we want to be able to describe the issues that contribute and be ready to answer questions that directly ask about digital divide or implicitly ask about them through a specific answer choice. So let's do this practice question here. A local government wants to improve public health outcomes by leveraging mobile health technologies. So which of the following, oh, sorry, the goal is to help residents monitor their health uh, and access medical resources more easily. Which of the following initiatives is least likely to help this goal? Armand thinks D. No worries, no worries. Is Armand the only one that's gonna vote? I can't believe this. Guys, you need to do your civic duty. 26.2 marathon. Yeah, I remember that. That was a fun question, right? What was that? That's Saturday, I think, right? Yeah. All right. So, let's take a look. Launching a mobile app that sends reminders for vaccination regular checkups. Well, this could actually contribute a little bit, right? Because you're kind of separating the people that have access and don't, right? But it's not actually going to contribute. Like it's not physically going to contribute. It's going just to implicitly contribute, if that makes sense, right? And so we want the least likely. So let's take a look at other options. Providing free wearable fitness trackers. Again, this is actually going to help with the digital divide if you're actually providing people with wearables, right? Hosting health education webinars and workshops in community centers. This is not having to do with any sort of digital, networks or anything, right? No computing devices or anything. And then D, which is the answer, replacing all in-health services with digital-only appointments. Obviously, this is going to actively contribute to the digital divide, right? Because if you only have digital appointments and there's no in-person health services, then obviously that's going to contribute. So, computing bias. Let's see. So real quick, what is bias? You guys had to define it. Yeah, it's when one group is treated preferentially over another one, right? Or it's when, yeah, so it's like when you have favoring one side due to emotional or personal preference, be it accidental or purposeful, absolutely, right? So if you are so much more easier than the processes, yeah, this is a little bit more common sense, right? Yeah, so that's you guys pretty much nailed it right on that. Nailed it. Nailed it. What's it called? Hammer on the nail. Whatever. You guys know what I'm saying. You guys got it right on the money. There you go. So, how is bias reflected in computer programs? What do you guys think? What are some ways that bias can be reflected? This kind of gets back to Unit 1 as well, if you guys remember that. Yep, so you could give inaccurate data to your like training, right? Or not accounting for a particular group of people or something like that. Yep. This also can get into the perspectives of people who are creating a digital program, right? If you guys have a very narrow kind of perspective of the people who are working on a piece of program or a program, right? Then the end program is going to not take into account the whole kind of user base that could actually be using it, right? So knowing that bias exists, what can computer programmers do? Training the program wrong? Absolutely. How can we try and reduce bias then? Get diverse input, right? Absolutely. Machine learning give them all variances of data. Yeah. So we can take actions such as, let's see, used for computing. It doesn't look like the CED actually specifies any specific actions that you can do, but it just basically says you can take actions, right? So, but we know from Unit 1 that we can incorporate more perspectives. So explain how bias exists in computing innovations. This is a good one to know. And then as far as this multiple choice question, let's take a look. A, B, C, or D. Oops, I didn't put D there. Well, if you guys think it's D, then don't vote. So what is one effective way to eliminate bias when developing a computer program? Yeah, this is a pretty straightforward question. We just kind of answered that question, right? It's obviously going to be C, include diverse perspectives during the design and testing phase. All right, let's go. Why is it not A, use only data from past successful outcomes? Well, if we only use data that's been successful, then we're not incorporating any other kind of options that we could see, right, as far as outcomes. Okay, crowdsourcing. So, widespread access to information and public data facilitates what? We'll say it facilitates. I'll just kind of fill it in from the CED, but you guys are welcome to say what you guys think as well. Identification of problems, development of solutions, and dissemination of results. So when we have access to information in public data facilities, we'll be able to do all these things a lot easier. So how has scientific research been affected by widespread access to information? Um, so in other words, if a lot of people have access to information, how has research been affected? What do you guys think? They've been able to conduct more research because more people have given them data. Yeah, absolutely right. So if we have more, if so, there's kind of it's twofold, right? First, if we have widespread access to information, we'll have a lot more information that we can conduct research with, right? And then the second option is if it's widespread, then even people who are not, in academia, right, actually doing the research can still do research, right? You can just Google something and you've done research, right? Because we have so much information out there. Um, so that kind of gets into this whole citizen science thing, which is essentially people who are, just normal everyday people, citizens, are conducting research science, right? So many of them who are not actually scientists can contribute relevant data to research using their own computing devices. They have been able to conduct more research because the people, yeah, exactly. All right, crowdsourcing. So, crowdsourcing, we just say, is the practice of obtaining input or information from a large number of people via the internet, right? So, for example, if you are on Kickstarter, right, and you need to get money to, you know, fund a project that you're working on or something, right? You can crowdsource that money, right? You obtain an input, which is the money, from a large number of people via the internet. So via this kind of Kickstarter campaign, right? So, how can collaboration via computing enhance human capabilities? What do you guys think? So, collaboration via computing or the internet, how can that kind of allow for more creativity? Maybe some examples as well. This is, again, very similar to Unit 1, if you guys remember, collaboration. More brain power, absolutely. Yeah. So you can combine the brain power from everybody together, right? For example, this lecture, absolutely, right? We can widely kind of disseminate information more easily, right? So Google Docs is a great one to kind of a great example to kind of use to say, okay, well, we can all kind of work together on a particular project to enhance our capabilities together, right? And how can crowdsourcing offer new models of for collaboration? Well, we can say they can connect businesses or social causes with funding, right? So that whole Kickstarter thing. So we want to be able to explain how people participate in problem-solving processes at scale. So let's take a look. I'll just kind of make this a new page here. So an online community, actually, I'll make the poll first and then I'll read it. So an online community of citizen sleuths has been investigating a decades-old skyjacking where a case where the perpetrator jumped out of a plane with a parachute and was never seen again. By analyzing publicly available FBI documents, historical flight data, and terrain maps, the group recently uncovered a new potential landing zone, prompting renewed interest from journalists and investigators. Which of the following best describes the role of crowdsourcing in this situation? Yeah, so a lot of us are saying B, right? Yeah. So this is a pretty straightforward one as well, right? Crowdsourcing is ineffective as in criminal investigations. No, of course not, right? The use of crowdsourcing can demonstrate how involving a wide range of participants can generate more innovative insights, right? Through expert evaluation is still necessary, or though expert, yeah. So obviously this is the right answer, right? Because expert evaluation, you still need somebody to verify your evidence, right? So it's always good to actually have, a professional be able to verify things that the crowd sources or the crowd, the citizen sleuths, right, have garnered. This case proves that crowdsourcing replaces the need. No, of course not. Crowdsourcing is only useful for data entry tasks. Obviously, that's wrong too, right? So, um, literally all they want you to know is crowdsourcing is good. When making code, get everyone's input, and crowdsourcing can solve any problem you can imagine, just as long as you have professional opinions as well, right? Absolutely. So, pretty straightforward unit crowdsourcing. Hopefully these ones are more of like the ones that take you 30 seconds, right? So you can take more like 5 minutes or so on the coding questions, right? Okay, so now this is where we start getting into a little bit more fun stuff for these last two units. So material created on a computer is the IP, or the intellectual property of who? What do you guys think? The user, right? The creator, right? Yeah, the creator or organization. So for example, if I create something for Five Hive, it is the property of Five Hive, right? It's not technically my property. All right, true or false? Measures should be taken to safeguard intellectual property. This is pretty easy, right? Should be true. Yep. And then plagiarism. This is, I always feel like when I'm talking about plagiarism, I said this before, but it's like the brainwash effect, right? Right? Where it's just like Yeah, of course. I know I can't steal people's work and blah 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 blah, right? But it's good to know for the test that plagiarism, the use of material created by someone else without permission, and presented as one's own is plagiarism and it may have legal consequences. Okay, with that out of the way, we should be familiar, of course, with the following legal ways to use materials. So we have Creative Commons, which is a public copyright license. And essentially, whenever we as creators want to give the other people kind of the right to share, use, and build upon the work we've made, then we can use this kind of Creative Commons license, right? Open source is specifically for programs, and it's not theater. What is it? Programs that are made, that are made freely available and may be redistributed and modified. And of course, so for example, a good kind of example of this, if you guys ever have done any screen recording on your computer, one program you may have used is called OBS, right? Open Broadcaster Software. It's an open source program that allows anybody to kind of see the code, see how's it working, right? And be able to use that program for free. An open access is on online research. So this is more research focused, right? Output free of any and all restrictions on access. So these three we need to be super familiar with. They will definitely ask you about these types of questions. So any questions with these three things, Creative Commons, open source, or open access? Okay, in that case, let's continue. When using material that is someone else created, we should always cite our sources, right? We know that. Um, and then for this one, which of the following raises legal ethical concerns? Using technology to harm someone or a group of people, computing in social and political issues, right? And digital divide. No need for spoilers. It's pretty, this one should be D, right? Uh, yeah, yes, A is true, but also, B and C are also true, right? So all of them are true. So we want to be familiar with the following computing innovations that raise legal and ethical concerns. So the development of software that allows access to digital media downloads and streaming, the development of algorithms that include bias, the existence of computing devices that continually collect and analyze data by monitoring activities, right? So for example, if we're streaming something, or if we're kind of video streaming 24/7, right, that could be a privacy concern. So there's a lot of privacy things that are going on here as well. That will come up a little bit more on the next subunit as well, but these are all things to be considering as well. So any questions so far with 5.5? Some other things that we didn't mention that are in the CED that you guys should know, Creative Commons, open source, and open access have all, so all three of these, have all enabled broad access to digital information, right? And as with any technology or medium, using computing to harm individuals or groups of people raises legal concerns. Okay, so let's do a practice question then. Which of the following computing innovations is least likely to raise an ethical concern? This is pretty similar to something that you could see on your test, I would say. Let the votes roll in. Yeah, so it looks like we're pretty much all saying A. I would agree with that. A calculator app that solves math problems step by step. You could think, um, yes, we'll go over D as well. So this question is so funny because it's totally something. Yeah, so I definitely like could see them putting this type of question on the exam because it's pretty straightforward, right? Just ethical concern, just testing that. And these kind of scenarios are also good. So let's go over B first, an artificial intelligence model that removes a watermark from image. Obviously, that's super not great because if something's copyrighted, it's straight up disrupting the copyright. It's getting rid of that, right? So we don't want to do that. An autonomous program on social media, the platform that repeatedly sends hate messages. Obviously, this is this is not good, right? That's getting towards the whole harming group of people, right? So we don't want to do that. A video recorder that records and monitors a public boat arena all day. So this has it's not the it's this is certainly not the most likely to raise an ethical concern, right? But I wouldn't say it's the least because something that records or streams something 24/7 always has a risk of causing an ethical concern. So that's something, for example, software that allows access to digital media and streaming, right? So streaming is the idea there. Let me see if I can find anything else here. But you say that A could be used to cheat, and specifies it's a public location. Yeah. So the way I was kind of thinking about this, right, is A, calculator app that solves math problems step by step. You could use it as a cheat, but if you're a teacher and you know about this app, you can pretty simply restrict it, right? And so say no access to any digital things or anything, right? So you can kind of have people not use that, right? So, as far as a video recorder that streams all day, the people who are being streamed don't know that they're being streamed, right? So, um, yes, it is public, right? And it could be kind of considered the security, but I would still say that A is more, or I should say less likely to raise an ethical concern, right? Cool. Yes, D kind of invades that personal space. I think there was something in the CED. I won't look for it now because have a little bit more to do, but that specifically mentioned something about streaming, like 24/7 streaming. So 5.6, safe computing. This is our last topic for the day, but it's a long one. There's 2 pages of stuff, so we'll kind of get through it here. What is personally identifiable information? What are some examples? So what do you guys think? Can you guys give me some examples of PEI? Full name, birthday, date of birth, great. Social security number, perfect. Right? Phone numbers, medical information, IP address, passport number, biometric data, financial information, all that kind of stuff, right? Something that you can just use to identify an individual, right? It's something that more specifically links, relates, or describes them or identifies them, right? Great. Search engines can record and maintain a history of searches made by users. Is that true or false? You don't need to spoiler for oh, I got you. You did all of them. Yes. That one's true, right? Because um obviously it's true, right? If you go on Google, you can see your search history, right? It's pretty straightforward. Websites, so it's just good to know that, obviously, right? Like I've said, these are more of common sense stuff, right? Websites can record and maintain a history of individuals who have viewed their pages. Again, true, kind of common sense stuff. And then devices, websites, and network can collect information about a user's location. So this is true. Some browsers and whatnot will have you specifically say that you want to, allow the site to kind of track your location or whatever, but it is true in general, right, that they're still able to do that as long as you give it permission. So, something we need to know. Technology makes it easier than ever to gather, use, and exploit information about certain people, groups, or institutions. So, um, just kind of straightforward, something we should know, right? So, how do search engines use your browser history? Here's a good question for you. What do you guys think? Yeah, so they can personalize advertisements, right? Or target you for marketing, right? They can also kind of use your past history to give you suggestions for websites that you might be looking to look at, right? To give you more items based on your searches. Yeah, exactly, right? So give you more likely websites that you're trying to look for example, right? Great. Um, how are disparate personal data such as geolocation, cookies, and browsing history used? Same kind of thing, right? They can create well, Nadine, what do you think? I see you typing. To show you fast food places around you. Sure, yeah, right? Like just to kind of give you or create a more kind of aggregated knowledge base of a specific individual, right? So they can make what they call a profile of you, right? And so that and this is kind of getting into more marketing terms and stuff, right? But you are then kind of grouped in what are called populations, right? So you can be put in different populations. For example, if you really like McDonald's, for example, right? Fast food places, um, then you may be searching for McDonald's. You may be located next to a McDonald's, right? And so you're going to be placed in this kind of, okay, we want to target these people if we're targeting ads for McDonald's, right? Because you're in the McDonald's population. So they can create these kind of really detailed profile of you using this kind of data. And that's how they're going to be used. So, what are some ways that putting your PII online can enhance your experience? So, obviously, it could negatively affect your privacy, right? But as far as how can it enhance it, well, you can give personalized recommendations, right? As we kind of said. The other kind of things that you need to know, they can be used to enhance your user's online experience, particularly using online purchases, right? So if you store your credit card information, for example, on a website or a store, right, Walmart, for example, then you can really easily kind of pull that back up the next time you're going to buy something from Walmart, enhancing your experience, right? So um, online purchases is another thing to take a look at. So if privacy protections are ignored, what can happen to your information? What do you guys think? Leaked, right? It can be all of your information can be leaked to hackers and whatnot, and get you can get your identity stolen, whatever, right? Absolutely. CED says commercial and governmental curation of information may be exploited if privacy and other protections are ignored. So it can be exploiting your information. So how can information you place online be used in unintended ways? Or maybe some examples. What do you guys think? Yeah, it can be leaked to people who haven't seen it, right? So whether that is, for example, used in ads, yep, that kind of thing that we're talking about. Maybe more specific examples. For example, an email, it may be forwarded to somebody that you didn't intend it to be forwarded to, right? Or tweets can be retweeted. Social media posts can be viewed by potential employers, right? All this kind of stuff we need to know. Use your credit card info to make unwanted purchases. Absolutely, right? It can be used to predict information such as social media. Yep, absolutely. It can be used to hyper personalize ads. Yep, great. So all these are ways that they may be used without your permission, right? So once it's online, it can't be taken off, that kind of thing. So what are some major ways that personally identifiable information can be exploited if in the hands of the criminal? We kind of said that, right? Um, they can kind of collect your information, location, record where you've been, how long you've been there, how you got there, that kind of thing. So that's not great. Oh, and that's actually this bullet point right here, right? Programs can collect your information where you've been there, all that kind of stuff. This is all true, right? Yeah. Identity theft, absolutely. Identity fraud. So once it's online, it's difficult to delete. We kind of said that as well, so that'll be true. And combining information posted on your social media and other sources can be used to deduce private information about you. Exactly what we've been saying, right? So all of this is really similar to itself, right? Basically, once you put something online, it's very hard to get off and can be used for not great things, but it also could be used for enhancing your experience as well. So, an authentication measure. How can we use authentication measures to protect our information? So, first of all, what is an authentication measure? A password, right? That's a great example. Yeah. So there are ways that we can protect devices and information from unauthorized access, essentially, right? So yeah, biometric, physical, passwords, steps you take to secure your info. That's a great way of putting it. Absolutely. So examples, like we said, are passwords and multi-factor authentication, right? All right. Characteristics of a strong password. So this is pretty straightforward, right? It's something that's easy for you to remember, but difficult for someone else to guess, right? So the way I was always taught was take some really long string of words that have some meaning to you. So whether that's like I don't know, like uh your favorite quote or something, right? And condense that down to the letters and then add in a special character, number, something that you can easily remember, right? Yeah, absolutely. Like Armand's name. Yes, exactly. All right, so what is multi-factor authentication then? What do you guys think? Should take a minimum of 5 tries to get right. Okay. Yes, biometric physical password. Right, that kind of thing. Yeah. It's when you use more than one thing to log in. Yes, that's exactly right, right? So it's a method of computer access control in which a user is only granted access after successfully presenting several pieces of evidence to authenticate themselves, right? So multiple steps to ensure that it's you who's trying to access your info. Absolutely, right? Authenticator code and password. Yes, great. Requires multiple factors of authentication, such as it could ask you for your password and then send a code to your email. That's a great example. Yes. So as long as you have multiple separate pieces of evidence to make sure that you are who is trying to log in, right? So there are some categories of this that we should know. So we have knowledge, so something you know, obviously. We have possession, something you have, and you have inherence, which is something you are. So typically you want two of these three things at least. So for example, a password that you know and a phone that you have, right? That makes a good authentication, right? Or for example, a um a uh, a password that you know and a security question that you created, right? That you are. I don't know. Make sense? All right. So encryption then. This is where we're finally starting to talk about encryption, right? So we want to say that encryption is pretty much just taking data. So the whole thing, right? Remember how that packets question was talking about encryption? That's right, but it's encryption is replying to the whole piece of data, right? So we're encoding that data to prevent unauthorized access, right? Um, then decryption then is just the process of decoding that data. So two common pieces or two common ways of encrypting pieces of data, right? So what is symmetric key encryption? So we remember? This is like the stuff I always would forget in APCSP. The easier one to solve. Yes, it's easier, right? Because it uses only one key. Exactly. So one key for encoding and decoding, right? Because so it's symmetric, right? So you send it off. So for example, you if you're trying to encode a piece of data, you would say, okay, I'm going to use this key to create a code for this data, right? And then I give that piece of data to somebody else, and they have to use that same key to then decode it, right? What about public key encryption then? It's asymmetrical, which means that it uses a different key to encode and decode. Absolutely, right? Can you, generally one of the most brilliant inventions out there. Absolutely, for sure. Can you guys remember though which one is the public one and which one's the private one? So which key is public, which key is private? I'll be honest, I don't know what those things are. So I don't think you have to know them for the test. Public key is the one that's used to encrypt. Private is the one that you have to decrypt. Absolutely. So public. So if anybody else knows what RSA and SHA 256 is, then feel free to answer that question. Public key is for encoding and pri private key is for decoding. Just Googled it. Perfect. All right. So then what is a digital certificate then? What does a digital certificate like tell us? You're good. What does a digital certificate tell us about just what does it tell us, right? Or what is a digital certificate? Yeah, it tells us that a specific key belongs to us, right? So we're able to use it. It's safe to use. used to verify the authenticity of a website or data. Yeah, absolutely, right? So they're they can validate, right, the ownership of a certain key, a certain encryption key used in secure communications. And what we say is that they're based on a trust model, which basically means we trust, if you have a digital certificate, we can trust you to use this key, if that makes sense. All right, any questions with this whole like encryption stuff before we move on? Okay, so what is a computer virus then? Great, no worries. So a computer virus. Our computer is sick. Oh no. It's a piece of software that causes havoc on another computer. Absolutely, right? So, um, malware that spreads through your computer that can delete files. That's a great example. That's a great example of a virus, right? And that actually is a perfect answer for what malware is, right? Which is um, malware is a specific software, right? That's intended to take damage, or sorry, to intended to damage a computing system, right? Or take partial control over its operation. So that's exactly what you said. So that's great. Now, a computer virus, though, is any sort of malicious program that can copy itself, right? So just like how a normal kind of virus kind of in your body would copy itself over and over again to infect you, right? The computer virus copies itself over and over again to gain access to a computer in an unauthorized way. Pretty simple, right? So computer viruses often attach themselves to legitimate programs and then start running independently then on a computer. So a scanning software um, can be used to protect your system by scanning to make sure that you don't have a virus, pretty much, right? Um, so that would be what's then a computer virus versus the malware, which we said was just intended to take over the computer by not necessarily kind of repeating itself or copying itself over and over again, but just pretty much just straight away taking over your computer, right? So, how can software updates help prevent compromising flaws in computer systems? Well, when you download a software update, what you're doing is really updating the or fixing some of the errors that could compromise your computing system, right? That's kind of what those software updates are allowing you to do, right? So like, for example, if your Apple phone releases a update, a software update, some of that may be helping to fix or put band-aids, right, over some vulnerabilities in your system. All right, so true or false? Users can control the permissions programs have for collecting user information, and users should review the permission settings of a program to protect their privacy. This is pretty straightforward, right? Oh, you think it's a tricky one? Let's see. So users, um, so Armand's saying that sometimes they don't give you permissions. So, uh, I think the idea is that Mars says, "Am I supposed to do?" Uh, yeah. So yeah, you can do the spoiler if you want. You don't need to though. For true or false questions, it's not a big deal. Yeah, don't worry. So the question is, users can control the permissions programs have for collecting user information, right? The idea is that all programs should allow you uh, to kind of control what permissions you give it, right? So the simple answer is yes, this is true, right? Because if you have a program, the idea is don't overthink it, right? A if you have a an app, for example, a smartphone app that is collecting your location, right? So say on Snapchat, right? Your Snap Map, right? You can provide that information to it for a better experience, like Nadine is saying, right? But you don't have to if you're concerned about your privacy. So that's all this is saying, right? All right. So, phishing. What is phishing? You guys remember? So when they send an email or digital communication posing as a legit actor trying to have you do something and then steal your sensitive info. Isn't it malicious links sent through emails or texts? Yeah, exactly, right. So essentially, you guys are both right, right? It's an attempt to trick you into providing personal information, right? And that personal information can then be used to access, bank info, sensitive, credit card statements, whatever, sensitive online resources, such as your email, bank accounts, whatever. Whenever I get a phishing email, I always make a point to go into the virtual machine and mess with their database by spamming the filling form. That's a great idea. Um, so yeah, it's like, when your Nigerian prince emails you, right? Asking for money. Don't do it. All right, keylogging. So what is a keylogger? This is a more obscure one, I think. Yeah, so it tracks your keystrokes, right? So mouse, I'm not sure if mouse is a part of that or not, but it's more like for sure that you can track, for example, if you click a website link and you enter your bank info, that's tracking your what you're typing into your computer so that you actually accidentally give them your information, right? Your cursor, yeah, right, absolutely. All right, so they record every keystroke made by a computer user in order to gain fraudulent access to passwords and other confidential information. That is very interesting that they did that. All right. Um, oh, you didn't mean to leave it. Okay. As soon as I started commenting, I was like, you deleted it. I was like, oh, maybe I shouldn't talk about it. But yeah, that's very interesting. No, that's very interesting that they charge you like 56 cents or whatever. That's cool. All right. So, why are public data networks dangerous? So, for example, if you're accessing Starbucks, public Wi-Fi, why could that be dangerous? Yeah, because your info in a public setting isn't encrypted, right? So they can't really use encryption on a public network, or else it doesn't become public, right? So yeah, you could be attacked if that was a rogue access point, right? So data sent over public networks can be intercepted, analyzed, and modified, right? So one way that this can happen is through a rogue access point, which is a wireless access point, so like the Starbucks Wi-Fi, that gives unauthorized access to secure networks, right? So if your network is secure, then you could be attacked using a rogue access point. So yeah, so you can use a VPN to kind of hide your location or hide your access, if that makes sense. And that protects you then from those kind of rogue access points and people kind of trying to hack into your computer kind of thing, if that makes sense. Or at least trying to get information from you over that public Wi-Fi, I should say. Okay. So how can malicious links be disguised? Here's a good question. We're almost done too, by the way. Yeah, so that's a great example, right? Using a URL shortener. That's a great one. So it can be kind of disguised on a web page or an email message or something like that, right? So it's pretty straightforward. It's just kind of the idea that you could be given an email that looks like a real legit email that has a real legit looking link in it, but it's actually malicious. Yeah, so it's emails, text messages, web pages, all that kind of stuff. So yeah, exactly. Using real company names with errors is a pretty common example. So if you see, your name is, spelled wrong, for example, yeah, or like using a different URL, exactly. All right, a freeware site, shareware site. So these are different, but we need to know what both of them are. Um, so never heard of it. Okay. Yeah, so freeware is giving you kind of access to free software, right? So untrustworthy or often free downloads. Here, let me. Freeware is free hot. So, yeah, so freeware is no cost. Shareware is free trial. Yeah, that kind of idea. Absolutely. Do we need to know this? Yes, it's the very last bullet point in the CED in this section. And I can kind of just read you. So here, let me just read you what this says. So untrustworthy, often free downloads from freeware or shareware sites can contain malware. So um, we pretty much need to know that they exist, right? Freeware is the idea that you can get something for free, right? It's like a free software, right? Shareware is the idea of posing as somebody kind of sharing their software, right? Or a free, you could kind of think of it like a free trial, but it's a little bit blurry, right? They're pretty similar. So, um, yes, sorry. If you go to that link and you go to list view and CSP 4 and 5, it's this document right here. Yep, not a problem. I'll do the whole thing as well. So if you want to also leave any feedback, you're welcome to complete that form, positive or constructive. I'm happy to get both, and I review them frequently. And then the other thing is here are the past uh, lectures as well, in case you would like to take a look. All right. And so that should, by the end of this lecture, we'll have all the units done. So for the exam, great, wonderful. So for the exam, we wanted to describe the risks to privacy from collecting and storing personal data on a computer system, explain how computing resources can be protected and misused, explain how unauthorized access to computing resources is granted, and AP, things I've noticed, AP loves to test things in this unit, especially privacy, encryption, and phishing. So any questions with this unit that we kind of went over? I know it was a long one, so if you guys have any questions, feel free to ask them. Will the other AP classes also be recorded on the 5? Yes. So if we go to 5.5, you can see there's a ton of lectures. So there's been a lot of APUSH stuff, a lot of econ. I did a stats review, stuff like that. Um, you swear your teacher didn't teach this. That's too bad. This is like the very last kind of stuff, so you may just not have covered it yet as well. How exactly does a rogue access point work? So essentially, the idea with a rogue access point is it's a wireless access point that gives you unauthorized access to secure network. So the idea is it's unauthorized and it connects to a um, a network that should be secure, but it kind of gets into it anyways. Can I summarize? Yes, I can do that soon here. Did I also do music theory? I did do music theory last night, although unfortunately I forgot to unmute on my recording, which is not ideal. So I don't have that. Do the scalability? Yes, I can. So there we do have a couple more questions here as well if you guys want to do them. But I'll do real quick a summary of what we've done so far, and then I'll go back to scalability real quick as well. So the idea we did 4.4 and 5 already. So we pretty much did all of the course at this point, but um the internet, you just need to know all your vocab and also what the protocols are. Fault tolerance describes how a network can be fault tolerant by having a lot of redundant paths in it. Sequential versus parallel computing. Sequential is just doing all the tasks in order. Parallel is doing them splitting up by processor. So you do have multiple things going on at once. This is always going to be faster. And being able to do these questions are important as well. And then for 5.1 is pretty common sense. It's just there are good and bad um, effects of computers. Hate parallel. We can do more parallel questions if you guys want. Digital divide is pretty straightforward as well. There are good and bad things that come from, some people have access to the internet and some don't. Bias is always going to be reflected of just giving preference to some group or individual. Crowdsourcing is getting information or some other input from a large crowd, right? So over the internet specifically. 5.5, there's lots of legal and ethical concerns. Know these three things. We won't be able to do FRQs today, but yeah, we will be definitely able to do them upcoming. Safe computing, that's is the whole thing of like encryption, viruses, and phishing. So let's do these questions real quick, and then we'll keep going and the scalability thing. We'll do that at the very end. We'll do the scalability one at the end again. So Um, let's do question one, and actually let's see. Can you guys see all of the questions like that if I do that? Yes, great. Okay. So I'll make a bunch of polls here. So there's one, two, and then three is coming up. Perfect. There you guys go. All right. So real quick for number three, make sure we're reading least, right? All right. So looks like we're all in agreement for one and two. So this is good, and mostly for three as well. Yes, I will go over the answers right now. So, for number one, which of the following scenarios best represents a significant privacy concern related to data collection? So we have A, which is a fitness app tracks the user's heart rate and location. Location is the big one here during workouts and shares this data with third-party advertisers. B, user clears their browser history at the end of each day. That's actually good, right? Because that if you're clearing your browser history, then there's no way it's more unlikely that the browser will be able to create a detailed profile of you to give to advertisers, right? And then C, a student turns off location services on their phone during class. This has really no effect, right? I mean, if you turn off your location service, that's great. Especially if you don't want to know, like people to know where you go to college, right? That's great. But turning it off is actually, you know, good, right? It's not a privacy concern. Turning it on and having it track your location, that's going to be your privacy concern because then you can make a whole big, better, more detailed version of this profile of yours. And then D, a website asks to confirm you're over 18. That's pretty straightforward. It's kind of just like a yes or no, right? So you're not really tracking anything there. How there's 17 votes but only 13 people? Oh, it's because I turned on the setting that you can do two people. You can choose more than one answer. It's not that bad. It's not that bad. These two units in particular are not terrible. You receive an email claiming to be from your bank, asking you to click on a link and enter your account details to resolve an urgent issue. The email contains official-looking logos, and your claims your account will be frozen unless you act immediately. This scenario most likely represents um, a phishing attack, right? Absolutely. This is pretty straightforward. Key logging we said was tracking your key movements. Phishing attack is the email, right? Privacy concern is this is not, right? And a public key encryption. Well, the email could be publicly encrypted, but it's not really like the whole bank thing is talking about phishing, right? Yeah, three is definitely the hardest. Oh, I appreciate that. Thank you. Uh, cool. All right. So let's take a look at this last one then. So the following scenario least illustrates which of the following we mostly said D, C, and D, which is correct. So again, these are pretty straightforward, right? User, this is bad, right? Don't download things from freeware sites. This is also bad, right? Connecting to a cafe and unknowingly expose yourself to a rogue access point. That's not great. And these two are actually good things, right? Multi-factor authentication is good, and public key encryption is good as well. So these two are the correct answers because they're the least likely to illustrate risks. All right. Any questions with any of these three questions here before we go back to the scalability thing? Because I think somebody wanted to look at that. Public is more secure. The reason is because you have two different keys, right? The public key and the private key. So the private key is implicitly kind of implied with public key encryption, right? So if you have a private key, that's actually going to be make it more secure. So that's how I like to think about it. Yes. Yep. All right. Real quick, if you guys again want to leave any feedback or anything positive or negative, feel free to fill that out. When would you go over the coding part like Sudoku? Yes, so we did that. I'll send you the link. Here is it's this one. Send you a link here. That was Unit 3 review right there. All right. So, yep. Let's go back to the scalability question because I think somebody asked about that. So, what is scalability? We know that scalability is just when you have a system that is designed to work on a small scale, right, with maybe 5 users, right, then if that system has a lot of redundant paths, then when you increase the amount of people that are using that system, you have a more even distribution of the people that are going through each path, right? Whereas if everybody's getting overloaded into one path, right, then that system isn't as scalable, right? Because you could have a clog with so many people with joining. So the idea is if you can grow your system, if you can grow the input or the number of people using your system, and it still works well, then we call that system scalable. Does that make sense? I don't remember who asked, but that's the idea. Cool. All right, perfect. So yeah, that's gonna do it. I can send you guys this link, which is a small activity that I did go ahead and prepare, but we are over 2 hours at this point, so we're not going to get a chance to do it. But if you guys want to take a look, you guys are welcome to do it on your own. And again, if you have any questions, you're welcome to reach out. My DMs are always open. Cool. Here again, same. These are the same resources I've always posted on all of them, but we have the practice test. This is the guide for written responses, the CED, AP Daily. Yes, let me just send the doc straight up. There you go. Um, yeah, I'll just send all of these links again. There's the feedback form, like I mentioned, if you guys want to take a look and provide any feedback, that'd be appreciated. I need like a full practice exam. I do. I'll do that 1 second here, and this is the link here. Okay, so okay, take care, Armand. Okay, so let me scroll back up here. So I need a full practice exam. Do I have that? So this is the practice exam that was made as part of 5 or it used to be called A Project, and this used to be the logo. So there's that. It has not yet been ported onto our website, I don't think. So you guys will be taking a digital version, but this is going to be paper kind of. So you're welcome to do this one though. Still good review. Is the practice test on Monday? Practice test is going to be administered, and I don't think I'm going to use this practice test as the one that we're doing, but it is going to be next Monday. Yes. The difficulty of this practice test, I would say, is probably a 7 out of 10. It's probably more more difficult than you may expect, especially some of the Unit 3 stuff is a little bit difficult. Um, but other stuff is not. So it balances out. But I would think it's probably a little bit more difficult than not. How's the practice going to work on Monday? Basically, what's going to happen is everybody who gets there, I'm going to start at like 8:10 probably. I'll share a link to a practice test, and the idea is you're just going to have I'll do the whole proctoring thing. So you have say the whole spiel. It'll be the whole thing that you guys are going to see on your real test day on whatever the 15th. And what's going to happen is then you'll have 2 hours, of course, to do your multiple choice. I'll stop, do a break, and then come back for the free response questions. And it'll be the whole thing. 8:10, your brain's already dead by then. That's okay. You can do it and just give yourself some leeway, right? Are you going to do the other ones that are on the schedule? What do you mean by that, Arman? Is there an answer key for that? Yes, the answer key should be inside of the test itself. So there's 108 pages. So yeah, this is the whole answer key for all the questions. All of them have pretty detailed answers. Yep. Um, so let me see here. This is still going on. Yes, it is. Welcome back, Panda. Would you say some questions are basic sense? Yes, some of the questions are in the AP Computer Science Principles are pretty common sense questions. Um, like there are three more CS lectures set up. Are those? Yes, yes, those are me. So I have these next three questions, or these next three sessions right here. Cool. Any other questions I can answer for you guys? If not, then again, thank you guys so much for joining. You guys are always welcome, like I said, to reach out over DMs. You can send problems. I'm happy to send kind of answer explanations, anything like that. So if not, then yes, thank you guys again for coming and take care. See you guys next time. Yeah, of course. See ya. No problem. Yeah, you too, Mar. See ya. Thanks, Armand. See ya. Have a good day. Bye.